Hi guys, this is Dominic from Diode, and we today had our webinar about live video streaming, and there was a question about the protected mode sharing, and that's exactly where we left off the last screencast when we showed how Diode publishing works, but we didn't quite go into protected mode. If you're curious about the webinar and the live video streaming, you can check that out from our website. It's linked there. There's a video stream, and you also find it just on our channel. And Peter is going there really nicely through how you do step by step from plugging in your camera into your Raspberry Pi up until you share it with like the whole world and everybody can watch your video stream. So if you're into that, check that out. It's really easy to do. And let's talk now about the nitty-gritty details of protected mode sharing. So last time we showed how you publish a port. So I want to publish my SSH port. I'm going to do it with public. That means anybody can access it. Bam. So now we see this client address has published that SSH port externally in the same name publicly. That means anybody on the whole planet can access it. And luckily, SSH has a second layer of security. So you still need an SSH key to log into my machine, but it's available on the whole planet. So I want to use it from down here. There's a second client. And I'm going to use a different wallet. So I'm going to call this new wallet 3. And I want to bind to this connection up here. I'm going to bind it locally, port 2020. I'm going to select the client address. I'm going to select the port number. And I'm going to say publish, which just means I'm going in the publish mode. I'm not actually publishing down here. I'm just binding. And it says starting the port bind. The port bind is active and we're good to go. So at this point I put this into background so it keeps running, but now I want to try it out and I'm going to do SSH localhost minus port 2020, and this is going to connect locally to this bound port, and that then goes through the Diode mesh network into this destination. Now this happens to be on my very same machine for this demo video here, but it could be anywhere on the planet, and in fact that's the way we do it when we connect anywhere to a Raspberry Pi that's in different offices. So I do this. That works as expected because it's publicly shared. If I stop the share down here, we will see it does not work at all. It says this device is offline and the error message, the detailed error message is not found. So I'm going to stop that as well. It doesn't work. And now I'm going to do the protected mode. Now what happens in the protected mode is that it's published to anybody who is in the same fleet. So now it's about the second entry here, the fleet address. So if I now try to connect, it tells me the device is not in the whitelist, and this is the very device here that I'm using right now. That's 7 dB. That is my identity. This is up here, 7 dB, you see. So I'm not whitelisted. And that's obvious because we're not in the same fleet. So I want to create a new fleet, and I would want to put those two devices in so they can talk to each other. And that's the whole idea of the protected mode and fleets. You can define a fleet as a group of devices, and everybody who is in that group can talk to each other, but nobody else. So for that, I'm gonna go back to our browser here and go to the Prenet browser. There I go to Fleets, and to use the Fleets panel you have to have MetaMask installed currently, so that's up here. MetaMask is a tool you can get from the Firefox shop. It's an open source tool you can use with the Diode network, but you can also use it with Ethereum network. It's totally compatible. So when you have done that and enabled MetaMask, it will show you this, and I can create a new fleet because I don't have a fleet yet. So I'm creating a new fleet. Creating a fleet means actually deploying a smart contract, and that is a transaction. Now the MetaMask window here pops open and asks me to confirm the transaction if I really want to do this and sign it with my private key. So I'm checking this. It's actually costing me nothing. It's costing me 0 because it has a 0 fee. And that sounds awesome. So I definitely want to do this. I confirm. And I'm submitting this. My new fleet contract is on its way to the blockchain. A new block takes roughly 15 seconds to be produced on average, but sometimes it's faster and sometimes you will see it's slower than that, depending on how quick after each other they come. Now this actually stopped running here, which means my transaction is confirmed. So I'm going to reload the page real quick, and we see we got a new fleet contract. And it looks like there's a ton of devices, but this is actually not the case. Actually, all of these devices are not fleet members. These are just devices that the website remembered that I used before. So this, in fact, the first one is in fact the very device I have here. That's my default account. We will find that up here, the 55C8. That is my default account. So I used that before in this website, and so the website remembered that's one of the device IDs I'm curious about, but it's not a member yet. But I do want to make this a member of this fleet for this demo. So I'm adding this device. Same story as before. I confirm this, I check, yeah, it's really 0. That's cool. I won't not pay anything. I confirm this transaction. There you go. It's added. Now, second device. I need to check this second device's ID that got the client address 07DB. Copy. And I'm gonna paste that here. 07DB, add this device, because I never used that before, so he doesn't know it. It's also not a fleet member. I'm gonna make that also a fleet member. I'm pressing on the add button. Same thing happens. Asks me to confirm. I do confirm, and the device is being added. Again, this takes a while. I can actually change the website. It doesn't matter. I can go somewhere else. This will still work in the background. So I can go to the prenet browser here and actually look at the blocks and see how they are coming through. So there's 2 transactions. That's probably, here probably was my smart contract creation. This was probably my first device, and the next block hopefully will have the transaction with my second device being approved. And while that happens, we can go ahead and set up our devices, because now we want them to be in this new fleet contract here of ours that just has those 2. Well, for now only 1 whitelisted. Now it also got 2 whitelisted, so this transaction just went through. I'll copy this address here, the fleet address, and I'm going back here. I'm gonna stop the publishing because I want to change this device's fleet. It's right now 0x6FE and so on, and we want to change that. So I say diode config. But let's just check out the config values here. So we're currently in this fleet and the name is fleet. So we're going to say diode config set fleet, and we add a new fleet. And here we go. This is our new fleet, 979. Boop, updated. I can check it. Yeah, 979. There we go. That's exactly what we wanted. Now I'm gonna do the same thing again. I'm gonna start just using the history here, going back to my previous one. I'm gonna publish the protected mode. We see the new fleet 979. That worked. And now down here on our device, we could do the same. We could just do the same and set our fleet. But actually for the second device, we don't need to do it. What's happening now is that the first device is now, when we say protected, sharing all these ports within its own fleet. So anybody who is a member of that fleet will have access to that. Even though that this device is not actively using the fleet, it knows from the blockchain that this device is listed as one of the members of this fleet. So here I'm not gonna do set the fleet, I'm just gonna try to connect again. And we should actually still be running in background. We should still be having our Diode client running down here. So I'm just gonna do the SSH to localhost. And if you have enough blocks passed already, then this will work. If not, then we will still be rejected. And it actually worked. That's awesome. That was quite quick. So I can connect it now. So as long as we find these 2 devices in the same fleet contract, they can connect each other. And vice versa again, I can remove this device with another transaction, and then it will not be in that fleet anymore. Just check. Actually, that went really quick, and we saw like this is a couple of blocks behind already. So let's see how long this takes to remove the device. I want to remove this again from my fleet. I'm going to remove it. That is again a transaction. And I confirm this transaction. So this fleet contract is actually smart contract logic. And we do provide a default contract that is being deployed here. But if you're yourself a Solidity developer or a smart contract developer, you can create your own smart contract for your fleet. It just needs to follow some of the smart contract fleet interfaces, so we can check whether a device is whitelisted or not. But you can go way above and beyond that, and you can, for example, have a multi-sig contract, so you have multiple people who can make changes, or you could have like whole groups of devices being added or being removed at once. The logic you could apply is really endless. Just what you can dream up and engineer in a Solidity smart contract is the limit. So in this default contract, we do it one by one. Now it has been removed, and we will see that in the prenet, this already is here and is working through the blocks. This goes quite quickly, but in this case, for example, we only have 2 blocks here so far. And if it's 2 blocks only, the device up here will actually not yet believe in that. Every time you start the device, it will validate the network and show you what block it thinks is the most recent one. Let me just do that. Just starting up here. And it tells us the most recent valid block it believes in is 144. Yeah. Let's compare. And 144 is down here. So we removed the device here, but our master device is still here. So it doesn't know yet that we have removed the second device. So at this point in time, when I SSH in, it should still work, and it does still work. Now this device does in background update this, but it's always gonna be lagging behind. And the amount of blocks it lags behind is usually like around 8-ish blocks. It depends on the internals of the BlockQuick algorithm, but it's usually around 8 blocks. And we can just do that. If you want to see, we just restart it, because then every time he prints it out. So we are 148. Let's compare that. We're waiting. Oh, we're just waiting for 148. So at this very block, if it believes in this block, then it must have seen the removal. And so it means this device, the second device, should not be able to SSH anymore. Bam, we're not on the whitelist anymore. This is it. This is how it works. You can add to your fleet contract as many devices as you wish. You can play around with that. You can set up a group of devices that can talk to each other, that can bind ports, do direct communication. And remember, every time these devices do direct communication to each other, the communication is end-to-end encrypted using certificates from both of these peers. So no server in between can ever read the data. It's really end-to-end encrypted. And so you got your blockchain managed group of fully end-to-end encrypted device communication. Have fun with that, play around. Let us know what you find and what you think. And if you find any bugs, shoot us an email, shoot us a message on Telegram, and we're going to look into it. Thanks.